Welcome, everyone, to the Polarian series of webinars. Today's presentation, Continuous Build and Delivery, Driving Speed and Control for Enterprise. Thank you for joining us, and we will commence shortly. Now, I'm very pleased to have with us today our guest presenter, Tracy Reagan. Tracy Reagan is the co-founder, the COO of OpenMake Software. Tracy has extensive experience in the development and implementation of standardized build and release processes for Fortune 500 organizations. With over 20 years' experience, she is keenly aware of the challenges large organizations face with moving toward a centralized and repeatable DevOps standard. Ms. Reagan received her Bachelor of Science degree in BA in Business Admin, California Polytech University. Also joining us today is Reg Strouk. Reg Strouk is the product manager with Polarian Software. With over 20 years of commercial software development and testing experience, Reg has held multiple positions ranging from the head of technical product management at Agfa Healthcare to most recently the project evangelist for Polarian QA. He has developed for several software testing tools such as Test Integrity, iTest, and Polarian QA. Reg is dedicated to the domain of test management and is continually analyzing testing trends and what impact they have on the discipline of software testing. I'd like to welcome both Reg and Tracy today, and I'd like to turn the agenda over to Reg. Welcome, Reg.
Thank you, Nancy, and welcome, Tracy. Good afternoon and good morning, attendees. Today, I'm just going to cover some of the grand topics that we'll discuss in detail. So obviously, we did introductions, talk a little bit about who is Polarian, in case you don't know who we are. Then we'll go into what is DevOps. We'll segue into also who's OpenMake. And then we'll have a discussion on the convergence of LM that meets DevOps. And then with the conclusion, we'll open it up to panel discussions and Q&A, hopefully for a good 10-15 minutes. So Polarian, we were founded in 2004. We're a global company. We actually provide a disruptive vision and technology in the ALM landscape. Instead of integrating, our philosophy is instead of integrating various silos of technology, we actually have a unified platform that is 100% browser-based with one repository that's based on various popular IP technologies, one data structure, and we include one business logic. The key strengths in our product that our customers love is the ability to have full traceability from the inception of code all the way to post-release management. Doing all of this and on demand from an intuitive UI. Really nice to see that we've had phenomenal growth over the last 10 years, in particular over 100% in North America in the last 2. We're totally bootstrapped, 100% cash positive, and then we've recently announced that we have an investment from Siemens of over $10 million US. You can see is we've got quite a few customers, quite a few users, and all kinds of different integrations and goodies. So here's a bird's eye view of the geographical landscape of our solution. On the left, you'll see that it's a component of 3 different licensing technologies, which actually is the same platform. We're going to highlight today is our ALM, which is the Application Lifecycle Management. Requirements Management is another one, and then the module for Quality Assurance Test Management. But as you'll see, right in the very middle is where we actually sit from a process perspective, and then all the different development domains such as requirements management, test suite management, audits and metrics, and post-release management, configuration management, so on and so forth, are all areas of the ecosystem that we manage throughout the entire development process. So I mentioned that we have quite a few customers. Here's some good examples. We actually also complement all of these different customers in our unified platform with a very integrated partner network, worldwide, by the way. And many of you, if you're familiar with Polarian, you might even have partners here on today's webinar, is that you'll see there's a very nice complementary ecosystem, as we mentioned the slide before, that focus on the other domains in development. And you'll see that there's actually some partners that are fully integrated. Actually, all the partners are fully integrated in the sense of providing us those, such as requirements management, IP management, data modeling that are fully integrated and managed by Polarian. Okay, having said that and giving you a bit of a bird's eye about who Polarian is, I am very happy to actually pass over the presentation now to Tracy. Welcome, Tracy.
Thank you, Reg. I hope you all can hear me just fine. Reg, is my audio coming in okay? Great.
Perfect.
So I am here to talk about the DevOps marketplace, but I first want to thank the Polarian team for inviting OpenMake Software to participate in this webinar today. So OpenMake Software has been playing and selling services and products in this space for quite some time. So we have some background in what companies are going through in today's environment in terms of building code, preparing it for release, and then deploying it, what oftentimes is now being called continuous build or continuous delivery. So where does DevOps fit in all of that? Because some of these terms often get confused. DevOps is really more of a process than it is any one particular tool. And it's the process of handing off source code or binaries from development teams back to those centralized release, testing, and production control teams. In that each of those teams, each of those silos have different roles that they play in the DevOps space. Developers are obviously the ones who are writing code, and when they compile their code, they deploy it for doing unit testing. And there are DevOps tools for helping with those roles, from coding, compiling, deploying, and actually doing unit testing. Even though you might have an agile environment, there is somewhat of a waterfall methodology in larger enterprise, where a different team will take on that testing functionality, but they will test at a higher level, oftentimes a model office or a system, maybe even an end user test, but they still need to do some of those DevOps steps, including many companies will have a final compile at the test date to ensure that the correct versions of the code are being released into the test environment before production. They have to deploy it, and they often then do their testing. Some of the testing tools that are popular here can help with simplifying those tests, minimizing test scripts, and also virtualizing some of those test environments. And then you get to what production has to do. And production really is responsible for doing the delivery of the binaries to those production environments. They have a whole set of different DevOps types of problems, meaning that you need to be able to support what the developers did and manage the technology stack that the developers need, but in the production environment. So these teams must talk, they must share knowledge, and they have to have some way of centralizing the control of all of these moving components. So we're talking about the evolution of development. And 15 years ago, everything was done really in a very waterfall methodology, whereby release cycles were very slow, sometimes 12 to 18 months. Over the course of the last few years, we've seen a rise in what we would call Agile Development, meaning that we are making smaller, more incremental changes in order to minimize the risk to production and increase the number of deployments to production, which means that everybody from dev through the test and production has more to do on a regular basis. And that's what we talk about when we talk about continuous. They're continually receiving new releases from the dev passing it on to test and test passing it on production, which means that it requires more automation than what we may have seen in the past. Again, as Reg pointed out, Polarian provides disruptive services, meaning that disruptive for processes that don't work well. How can we interrupt what we're doing that's not correct anymore? Down in the waterfall days, it may not have mattered if a build took 8 hours because you were going to do a full week or 2 weeks of integration and getting the build to work. In the continuous methodology, you need to have that done in a matter of hours. So I think we stop right here, and Nancy, could you take that first poll for us? So our first poll question here is, could you answer for us where you are in the evolution of development within your organization? Do you consider yourself waterfall, agile, or have you achieved some level of continuous delivery?
Tracy, that poll will run for 1 or 2 minutes if you want to just talk over it, and then I'll release the results for you.
Okay. So there is a very big difference between what the development teams or a project team might need to do for DevOps and what an enterprise may need to do for DevOps. And in many cases, when you see an agile process in place, it's built around what the developers are needing and are using. But that may not be appropriate, or it may not help the centralized teams that are supporting 35 or 40 project teams. So the enterprise DevOps challenge looks very different from what a single development team may be doing. At the enterprise level, they have a need to be able to keep up with the pace of new development. As this continuous process becomes more adopted, the development teams are turning over code to those testing and production control teams more frequently. So they need to move from a process that's more continuous and less monolithic. All right, we'll just take a quick look at that. You see the bar graph. It looks like most of you have moved away from waterfall and are moving into a more agile practice. And it looks like some of you are trying to move into that continuous delivery state. So another challenge that the enterprise faces is the need for tools to more closely align with cross-platform environments. So this ensures a standard process that can support both, say, Java and .NET, or Linux, or mid-range, or a Unix environment. Again, when the development teams define their DevOps process and their continuous integration or continuous build and delivery procedures, they often do it around a single type of a tool set. At the enterprise level, that tends to change. Not everybody at the centralized release team may understand how to use Puppet or write a Maven script. So what happens is that these diverse tools end up in the laps of a few individuals who then are responsible for understanding it and using it. So instead of being able to take control from that point, they go back to the developers to get help, and then it interrupts what the developers need to do. And the reason why they're going through this is because they need to be able to pass some level of internal audit. They need to show traceability and repeatability with the separation of duties. And there is where the bottleneck occurs. It's difficult for them to establish that traceability and the separation of duties, particularly when they're not familiar with the tools that are being used by the development teams, and they have to go back to the development teams for assistance. So to solve the problem, the DevOps for the enterprise becomes more complicated because they're having to solve DevOps for each of these smaller teams. So a common release process needs to be looked at, and a standard needs to be developed that will support all platforms. It should not be platform specific. It should be platform neutral. In addition, developers who write application that share data may need to run on the same user's end machine or server or even desktop. This requires a more coordination of the underlying technology stack. Everybody may need to move to the new version of Oracle at the same time, or at least everybody who's working off of that same technology stack. We see changes in the industry that are trying to address this, but personally, I feel sometimes that they're trying too hard to solve it by having everybody run under their own virtual environments. So you have multiple versions of the Java runtime. You have multiple versions of all these underlying structures and components, such as Oracle. That becomes more complicated at the production side. So what we're doing is, instead of solving problems over at the development side, we're starting to solve them in production. And oftentimes the mistake that I see is that the open source community has driven the discussion around both continuous integration, build and deploy, but that doesn't mean they write non-platform specific tools. So what happens is these environments are often heavily scripted, and it's may be executed through some sort of a CI process like Jenkins, but the back end can be very heavy on the one-off script side, and they can be brittle, and those centralized teams struggle with supporting it. So the result is the implementation of these project-based DevOps processes don't actually achieve the goals of the enterprise, even though they're achieving the goals of the project teams. So if you sort of look at the differences on the sort of the open source project tool side, many of these tools support Linux. They are based on scripting. Even a manifest file might be needed to be scripted for something like a Puppet or a Chef. The individuals who follow them know how to read logs, and it requires tribal knowledge. At the enterprise level, from the release team and the production control team, they're supporting multiple platforms. They have to have knowledge on demand. They can't take the time to look in a script to understand what that script might have done or why it broke. And they need actionable reports in order to achieve a higher level of maturity through the model. So what they need to do is minimize the fiefdoms and the tribal knowledge so that everything is more centralized and shared. So developers, instead of writing these, what happens in this highly scripted environment is the developers write their build and release scripts, and the production control team has to have their version. The developers have their technology stack, and the production team has theirs. The developers are focused on configuring the binaries, but the production control side manages the server configurations, a huge disconnect. The developers are managing the database changes, but when it gets to test and production, the DBAs might be managing those schemas. And in the same way, developers are managing their servers and their server changes, while the test and production teams are trying to manage those servers, another big disconnect. So what companies are looking at are moving to a more model-driven process, one that becomes more dynamic. You see this even in the open source community, that they're making the attempt to move to more model-driven, even though those tools still may be platform-specific. So for example, with Maven's build environments, you have archetypes, and with Puppet, you can have the modules that you can reuse. So reuse it becomes more and more important as you're trying to increase the speed in which you're turning over code from developers through production. These models control the build platforms and the release templates. They also actually control and help share the management of the technology stack, and allows the development teams to share how they're configuring their binaries to match what the servers will look like. It allows the centralized database teams to see both sides what's occurring, and to include in the build and release process the upgrade and the management of the database schemas, including data that may need to be moved across. So what we're creating is a point of control of the process that's shared between all three different silos. So most companies have started over here in the script-driven sort of continuous build and continuous delivery environment, whereby you have these teams writing their own types of processes, their own scripts for building out continuous build and delivery. If you just counted, if you are working now on a single project team and you counted how many scripts you may support for your multiple releases, you're probably going to come up with quite a few. Somewhere around 50 at a minimum. Now, what you've achieved, and those scripts again are written in things like Maven and Ant and Python and Ruby. What you have achieved is a highly customized environment that works well for your team, and it can be called by a CI server. So there's some automation. This is difficult for the larger enterprises to sustain because those exact scripts must be turned over to the centralized release engineers. Now, it's free to download, but it's actually costly to implement. And there have been studies on this that have shown that even though something's free to download, it's not free to implement. And these solutions are often focused around Java and Linux, which is sort of a primary focus for the open source community. When you move to a model-driven process, what you're doing is minimizing on the number of custom scripts, and you're maximizing on reuse. Once you do that, the process becomes not only highly reusable, but easier to debug when there is a problem. This becomes much more sustainable for the enterprise because you have fewer processes to manage. You move from managing 50 per team to managing maybe 10 or 15 for the entire organization, for both the build and the release side. When you take control of it at that deep of a level, you actually are able to do things like acceleration of your build and deploy. You do better dependency management. You can see better into the technology stack that can then be delivered over to the release team so they understand what the binary includes in it and how it should match the production runtime environment. Of course, these commercial model-driven tools, there's a cost to download them, but they're easier to implement once you've established the reuse in those modules. Ultimately, what you're given is build to release intelligence that's constantly derived automatically for good decision making, and they're cross-platform. So the result is these hundreds of one-off brittle scripts are reduced to a handful of these standardized models, which allows you to simplify the handoff between the central teams and the development teams with less staff. Auditability becomes less of an issue because these model-driven tools have better code scanning capabilities, and they have more insight into what is actually occurring than what the scripts can deliver, which allows for the control of the underlying technology stack. So these large applications with hundreds of dependencies are exposed, allowing you to increase the speeds of builds and move from those monolithic processes to more incremental processes. And that is exactly what is needed to really push the agile processes sort of up the chain in order to achieve faster and more efficient software releases. So if you think about this in terms of achieving maturity, when these team-based automation solutions are built out, they can achieve quite a bit. They can get up to a certain level of standardization within that single team. But once it moves up the process for achieving higher levels of maturity at the testing and production release states, a more model-driven process is needed to continue the speed of the releases. The software development lifecycle really has to be automated and move away from these one-off scripts that the centralized teams have to take control of. They have to have metrics to understand where the problems are. So you have to understand why a build may have broke, or why a release did not work even though it worked in test and it broke in production. You have to have the insight in order to achieve this process improvement. So continuous process improvement cannot be achieved when you have really, I would say, practices that were developed back in the early C days based on things like make. I don't mean to be critical, but make and ant aren't that different. There's still a scripted process that we did when we were doing waterfall. We have to do something different. There's better ways to do this, and automation in the SDLC process is required. So just a quick plug, but was there another poll we could would like to go ahead and do that second poll, Nancy, at this point? So now that you sort of understand what I'm talking about when we talk about DevOps, can you tell us where you're currently invested in the DevOps process? And we'll leave that up for a few minutes until you answer it, and I'll go through what our Meister and Release Engineer products are, and we'll see a quick demo. So OpenMake Meister is a continuous integration server that goes to one level deeper. It allows you to use models to control the compile and link logic of over 200 different languages. This allows the centralized build teams to take management or control over the build process without having to understand the scripts. In some cases, we've had customers who've literally have taken an inventory of their scripts for these large enterprises, and they'll have somewhere in the ballpark of 800 to 900 build and release scripts that they're able to boil down to a dozen. So we have, it looks like right now many of you are undecided about where you're at in the DevOps process, which is totally understandable. I think most companies who are really looking at this are stopping and not running towards it, and they're taking a strong evaluation of the tools that they currently have in place and how those tools can be used from a centralized process in order to really simplify that handoff between developers and production testing and production control. And it looks like some of you have started to do some of work in that area, but I think that DevOps is certainly an early, those of you who have achieved it are early adopters in the process. So coupled with our Meister product, we have Release Engineer that does pretty much the same thing in the deploy area. So instead of having deploy scripts that are executed by a CI process, the Release Engineer does two things. It helps package the software, and it helps release the software. So if you think about how we work within the overall SDLC, Meister integrates with source code repositories and does the translation of those binaries and stores those binaries. So it has its own binary repository. However, there may be companies who like to store those binaries back into an external repository. Meister also does all of the dependency management and the matching of source to executable so that everybody at the other side of the house in the release and the testing team understands what went into a binary. When the binaries are being released, Release Engineer does a first step, which is called packaging. That's taking up all of the components and putting them into what we call applications. And in some cases, there may need to be multiple applications released at the same time. So we can manage multiple releases at once, and we call that a release package. inside that release package is all the logic and how to actually start and stop servers, whatever massaging that needs to be done prior to the actual delivery. Release Engineer has a deploy component that then actually manages the server environments and what we call environments. You can have an environment that is a test environment, and inside that test environment, you could have a role of a server or a cluster of servers. So we have worked with the Polarian folks to create an environment that includes the back-end processing, what Meister and Release Engineer does, as well as what Polarian does well, which is manage the tasks and activities across the top. So we could turn this into a circle so it looks more continuous, but this would be a very confusing slide if we did that. And in any case, each of these silos, development, testing, and production, they themselves have their own CI process and things that they need to do that are different. And that's what we're going to talk about now. So we're going to show you a demo, about a 4-minute demo on this, but let me run through what you'll see, and then we'll sort of summarize what you have seen. So within the Polarian tool, we are able to create what we would call an ALM build record. And that can be done starting at the development, and it can be associated to a sprint. As the developers create and publish the binaries using Meister, we update that ALM build record with the item history, all the source and library dependencies, and what we would call a source to executable parity. At the testing state, that work item is really defined as a release candidate. Now, at that point, the testing team, should they want to, they could actually look to see what source code was approved and pulled into those binaries for deployment in their testing environment. Once they've done what they need to do, they can pass that build record item over for a release candidate for production with all of the associated information. And we will show you that in the demo, how that is kept track of. But each of these different silos have their own jobs to do and may need to do it in a different fashion. So for example, within the CI process, what developers need to do needs to be done a bit quicker, because they may be doing this on a more frequent basis than what they would send to test. So they need to be able to incorporate the creation of the build record into the performance of the compile process and the deployments to their servers, and ultimately into a release that moves over to the test environment. The testing teams need to be able to mark that release as a proper candidate, go through their testing, allowing the proper triggers to be executed so most of these steps can be done automatically so nothing is missed. We take as much out of the hands of developers and testers in the Excel spreadsheets that we can so that these types of human errors are not made. We're going to watch a quick demo. This was done by Quinn Bailey, who has done some work with the Polarian team and has submitted. He's one of the contributors to the Polarian tools for doing conversions. So we're going to go ahead and watch this demo. You're going to see how Meister and RE runs through a continuous build and deploy, and how ALM drives the process. It's only a 4-minute demo, so we're not going to be able to drive down too deeply into what all of this is doing.
The user story that indicates a task for a software developer to perform. When the developer makes the source code change required for this task and checks it into version control, they reference the ALM task work item in their commit message, which then results in the revision being linked to the task here. This source code change will also kick off an OpenMake continuous integration workflow that publishes the binaries to our binary repository, in addition to creating our build record work item and source to binary traceability document. You can see here that we've linked automatically because of the linked revisions. We know which revision we're building. We've linked the build record to this particular task that the source code revision implemented. So here's an example of a completed build record work item. It shows here the log URL. And if we want, we can follow this link to see the results of our build that ran, building a simple Tomcat War application. Here we can also see history of deployments that have been run against this build. Let me then also show you the associated source to binary traceability document. Again, we have linkage here to the build record work item, and the task that the specific revision implemented. Of course, there could be multiple tasks for that. We have basic information about when the build was executed. Again, a link to the log file. Here, down under source code dependencies, you can see, well, actually, library dependencies and source code dependencies, any dependency that went into the build. And we can also link to the specific source file and even get to the content of the source file this way. And then we also have down here a list of published binaries, including a SQL change script that's used to do database updates. Then we also have deployment information, summary about deploy to the development environment, deploy to test environment. We had one deployment to the test environment that was unsuccessful, but then fixed. And then also the deployment to the production environment. You see here also includes a list of binaries deployed, the environment, and the deployment endpoints. Now, if we take a look at a subsequent build record, we can then use Polarian's built-in comparison tools to see the differences between any two builds. So let me do that now. Among other things, it's particularly interesting to note that the comparison shows us the differences in source file revisions between the two versions of our application. So these were the source files that have been changed to produce the differences in these two files.
Right. Well, thank you, Quinn, even though he is not actually here to think. So let's just quickly review what you saw there. So what happened was we basically showed you a process that marked a build record for a basically ready to deploy. We were able to change the deployment status at one point from deploy to test or prod. The Meister workflow triggered the releases and performed the continuous build and deploy and updated the statuses, providing Polarian's ALM the build record for the binary traceability to show exactly what occurred. Now, it's important to note that even though this was a 4-minute demo, what happened on the back end did not require any type of scripts. Meister actually managed the compile of the war and did the deploy. It did not require anybody to write something customized. It used its standard models to do that. It also did all the code scanning, which gave all of the comparisons between the two builds and what was going to be released. So because we can get down into the compile process and actually manage it, understand what the source code is, scan it, make sure all the dependencies are correct, we can do that incrementally, we can speed it up, and we pass that information off to release engineer to pre-validate it so we could actually raise a red flag and say, and tell Polarian, we're going to stop this because the technology stack is now wobbled and it will eventually break. So what do you get from this combined solution? You get faster CI builds and delivery, less downtime. You get the incremental processing. And I hear developers tell me all the time that, well, Maven does incremental builds by default. Well, not really. What Maven does is it says if you have something in your jar that's been updated, we're going to delete everything and rebuild everything because it's so fast. Well, it might be fast, but when you do that, you lose the traceability. As soon as you delete everything under that particular jar and rebuild it, you don't know what class file actually initiated the change. And that's the type of traceability that larger enterprises are required to keep track of. So by minimizing the scripts and moving to something more model-driven, we lower costs in the processing and the maintenance and the fixes. And we minimize the risk to production because things become more repeatable and consistent with a full audit trail of all the objects used to build and release, with that managed inside of Polarian ALM. The integrated solution really simplifies the DevOps handoff. It achieves what we need to do in terms of streamlining that process. We defined in the beginning what DevOps is the ability to simplify. Well, we showed you a very simple way of keeping track of all the components and minimizing the reliance back on the development teams to actually do the work for us. That achieved a very high level of standardization, moving us up on that maturity model scale. At the end, there was full traceability of all the objects that were used because that again, is something that our large enterprise customers require, and actually they demand, and that even included the database objects. So again, we really simplified the use because we were able to do that from a model-driven process, highly automated, with Polarian ALM managing the task and processes from the ALM standpoint. And on that note, I am going to turn this back over to Reg and Nancy to handle any questions that you might have.
Thank you very much, Tracy. What we'll do is, if you have any questions or have any wanted points of discussion, we will keep this actually open for another 10 to 15 minutes at least.
I've got one here. Can Polarian ALM trigger a continuous delivery, and where are the binaries stored?
So in the demo that we gave you, the binaries were created by Meister. So instead of having a script being executed through the CI process, we actually compiled it with Meister and did the code scanning. And then the binaries themselves were stored back into the Meister binary repository. Those binaries could be stored in any external repository, and release engineer can pick them up from any location. But in that demo, we stored the binaries back in the Meister continuous integration server that includes a binary repository.
Thanks, Tracy. There was another question that came in with regards to the demo as well. It said, there was asking that we showed a build record and then a different report. Between these two builds, it showed the source files, and they were wondering if that has changed and how was that done.
So, unlike the scripted environments, when Meister calls the compiler, so it controls the compilers. When it controls the compilers, it knows precisely what source code it is passing to the compilers and linkers. So it creates what we call a build audit report. Now, this is different from a subversion bomb report, in the sense that if a object or artifact is being pulled from an external repository, not a subversion repository, it can still report on it because it's consuming it. So when Meister consumes a file to compile and link with, it records it in that build audit report. The build audit report then is used to create that build record inside of ALM, and it updates that information. So historically, you could then go back and compare any two build records to see exactly what was changed across the life cycle or between two CI releases.
Thanks, Tracy. The next question I can actually answer. They're asking whether or not they get a copy of this presentation after the event. And yes, you will receive an audio recording of the presentation. The next question, though, I think is for you, Tracy. What version control tools and development environments can this process support?
Any version control tool. Meister itself is integrated into about all of them, even some of the old ones. We still support the old PVCS and CVS. I don't know if there's anything on the market right now that the Meister does not pull in. So what it does is two things, actually. From the checkout, it's easy, right? That can be done by any CI server. But what we also do in the build audit report is to go out at the time that file is consumed by Meister in the compile process. It goes out and says, hey, I found this from a subversion repository. I'm going to go get the item history along with it. So inside that build audit report, you see if it comes from a version repository, you see the item history along with it. And again, it supports subversion, Git, Perforce, ClearCase, Harvest, PVCS, Dimensions, and some of the older ones like CVS and PVCS. And there's probably many that I haven't thought of.
There's lots out there for sure.
Yes.
I just wanted to mention as well as on the ALM side for Polarian, probably coincidental timing, but we actually just announced this morning at 9 Standard Eastern Time that we have a technology partnership with Perforce and actually direct integration. So we do integration as well from other areas, with Git, Subversion, obviously, in Perforce. where actually you can actually create defects that have a direct integration and link with any of the source control files. So there's a lot of different traceability, and obviously with OpenMake, that's really going to expand that particular ecosystem. Any other questions?
No, I don't have any other questions in the Q&A right now. So as you said, Reg, we can leave it open for a few more minutes. I will take this time to certainly extend Polarian's appreciation for Tracy joining us today, and for Reg as well. Someone has an additional question, but this concludes today's formal presentation, and we thank you so much for taking the time to join us today. Thank you.
Thanks, Nancy. I just want to add very quickly one other thing is that we scanned through the slide pretty quickly, but if you are actually interested in getting access to the integration between OpenMake and Polarian ALM, we did show a prototype in the demo today by Quinn. Feel free to either contact OpenMake or Polarian, and we will be more than happy to assist you in actually getting an early adoption. Thank you.
Great. Thanks, Reg.